Jonathan here at Colfax Math. In today's video, I'm going to go over interest, simple interest, compounded annually interest, compounded monthly, and then continuous compounding. Really interesting, has a giant impact on your life, whether you're borrowing money for a car or a home, or whether you're saving money for retirement. How compound interest works is really important. So I'm going to go over that in this video. One thing I will say is I'm in Northern California in the fall and fire season, and we've been out of power for quite a while now. Let me go over interest a little bit. So the first thing to look at is what's called simple interest, and this is no compounding at all. The lights are back on, so that's super nice. So simple interest, I is equal to your principal amount times your rate of interest times your time. So this is how much you're going to get back, and this is how much you start with. This is your interest rate, and this is the number of years. So let's say we're talking about $100 at a 10% interest rate for 3 years. Calculate simple interest. It's going to be equal to your principal amount, $100, times that 10%. We're going to convert that to a decimal, 0.10, times the 3 years, and we multiply those together to give us $130. So that's simple interest, $100 over 3 years at 10%. Let's take a look at compounding annually. So this will be compounding annually. So we'll stay with the same numbers. I have $100 at 10% over 3 years. The way I'm going to do that is at the end of 1 year, I'll have made $10 interest on that $100. The total interest will be $10, and then the total amount I'll have after that 1 year is $110. Same as simple interest, but the difference now is I could take that interest and start earning interest on the interest. So now I take that $110 and I start earning 10% interest on that. And I actually earn $11, right, because it's 10% on 110. So the total interest I've made so far is the 10 and the 11, or $21 in interest. And the amount I have in the bank now, after 2 years, is $121. The first year interest and the additional interest on the interest gives me $121. So now I'm going to start the third year with $121 in the bank at 10% interest over 3 years. Start the third year, 10% of the 121 is $12. So the total interest I've made so far is the 12 and the 21, or $33. And then the total amount I have after 3 years is $133. So simple interest at the end of 3 years would be $130. Compounding annually, meaning I would collect my interest at the end of the first year and then earn interest on that interest. At the end of 3 years at the same interest rate, I would have $133. And I could compound it monthly, hourly, by the second, and we're going to get towards compounding continuously. So this is the compounded annually amount I would make at 10% interest over 3 years on $100. And then the equation is the amount you're going to have is going to be equal to your principal amount times 1 plus the rate of interest divided by the number of periods that you're compounding it times the number of years times the number of periods you're compounding it. So if I'm compounding it annually like I did here, it would just be equal to my principal amount of 100 times 1 plus a rate of interest at 10%. I'm only compounding it 1 period per year, so that would be by 1 to the power of 3 years times the number of periods 1. So if I enter that on my calculator, it'll give me the same 133. So if I'm compounding it monthly, it's going to be that same equation. So compounding it monthly would be my principal amount of $100 times 1 plus that same rate of interest, 10%. But now, because I do it 12 times in a given year, I divide that by 12, and I take that to the power of 3 years times 12. So let me enter that on my calculator. So on my calculator, I'm going to do 0.10 divided by 12 equals, plus that 1 equals, that whole thing is to the power of 3 times 12, and then that times $100. So that gives me $134.81, actually 82 cents. If I did the first equation here, compounding it annually, it would give me 1.10, right? 0.1 divided by 1 plus 1 to the power of 3 times 1 times that $100, and they would give me $133, the same as I got right there. A little bit of difference of 10 cents because I rounded on this 12. The 10 cents is actually on that 1. So that's how you do simple interest, principal times interest rate times the time period. How you compound it annually, do you use this equation here, where n is going to be the number of periods in a given year. So that'll be 1 for annually. R is your rate of interest, T is the number of years, P is the principal amount, A is the amount you have at the end of the time. Compounding it monthly, I could set up a table like this and do it the way I did it for annually, but I'd have to have 36 rows in my table to do that. So now I'm getting to a place where I could only use the equation. I use that same equation. It's a principal amount, 1 plus the rate of interest, 12 because there are 12 times I'm compounding it in a given year, to the power of 3 times 12. And I can see as I do this over time, it's going to approach the number e, and that's how I compound continuously. So the equation for compounding continuously is A is equal to the principal amount times the number e to the rate and the time in years. So that e is a constant, it's right here. It's the inverse of the natural log, just like 10 to the x is the inverse of the log. So to use compounding continuously, my amount is going to be equal to my principal, the same $100, to the e to the power of my rate of interest, 10%, times t, the number of years, 3. And then on my calculator here, I have e, it's my second function, e to the power of quantity 0.1 times 3, closed quantity, 1.349 times my principal of $100, and that gives me $134.98. So that gives me $134.98. You can see there's a bit of difference between compounding annually and simple interest at 130. There's a little more of a bump up compounding monthly, and a little more of a bump up compounding continuously. But starting to decrease the amount of savings. And again, it depends if you're borrowing or lending money. So if you're borrowing money, it really has a big impact on the rate of paying it back. And if you're investing in things, your money adds up a lot quicker when you're compounded continuously. Another common problem is at these same rates and amounts, how long does it take for you to double your money? So for you to double your money, that would say, I want $200 out. When I put $100 in, I still have E, I still have the same interest rate, but my variable is how long does it take, so that's my T value there. First thing I'm going to do here is divide both sides by 100 to get 2. 100 divided by 100, which is 2, is equal to E to the 0.10t. The way I reverse or undo an e is a natural log, right? So here it is, ln is the inverse function of e. So I take the ln of both sides. Ln of 2 is equal to ln of e to the 0.10t. First property log says that could come down in front. So now I have ln of 2 is equal to 0.10t. Ln of e, well, ln of e, this thing's just equal to 1. But it's saying e to what power equals e? So this thing's equal to 1. So I have 0.10t equals ln of 2. So I take the natural log of 2 is 0.69. 0.69 is equal to 0.10t. Solving for t, I divide both sides by 0.10. And I get t is equal to 6.93 years. So if I am making 10% interest and I have a principal amount of $100, it takes me 6.9 years for that money to grow into $200. Okay, hopefully that helped you learn a little bit more about interest, the difference between simple, compounding annually, monthly, and then continuously. The amount you get back is equal to the principal rate, e to the power of rt. I remember that PERT, a equals PERT. I use that all the time, whether I'm figuring out financing solar for my house, buying a car. Is it better to have the money in the bank or use it to pay off a loan? It's a very useful equation to compound continuously. If you like the video, hit like button, subscribe, and I'd love to hear your comments below on how you use this equation. Thank you for watching.